Black holes are regions in space where an enormous amount of mass is packed into a tiny volume. This creates a gravitational pull so strong that not even light can escape. They are created when giant stars collapse, and perhaps by other methods that are still unknown. Black holes fascinate both the public and scientists. They push the limits of our understanding about matter, space, and time. Scientists at the University of Chicago and across the world have made many discoveries about our universe with the help of black holes. But there's a lot we still don't know about these extraordinary cosmic phenomena. What is a black hole? Black holes are made of matter, packed so tightly that gravity overwhelms all other forces. When you pick up a bowling ball, it's heavy because the matter is densely packed. If you packed more and more mass into the same tiny space, eventually it would create gravity so strong that it would exert a significant pull on passing rays of light. Black holes are created when massive stars collapse at the end of their lives, and perhaps under other circumstances that we don't know about yet. One of the first steps towards the discovery of black holes was made by University of Chicago professor and Nobel laureate Subrahmanyan Chandrasekhar, when he realized that massive stars would have to collapse after they ran out of fuel for the fusion reactions which keep them hot and bright. The universe is full of black holes. In the past decade, scientists have detected the signals of their collisions and taken images of the light from the gas swirling around them, and this has helped us learn many things about the universe. For example, black holes have helped us test Einstein's theory of general relativity, which describes how mass, space, and time are related to one another. Scientists think that they can tell us much more about these and other essential rules of the universe. And on a more personal level, the supermassive black hole at the center of our own Milky Way galaxy may have played a role in how Earth came to be here. What do black holes look like? Black holes themselves are invisible. They emit virtually no light, and so cannot be seen directly. But we have developed several ways to find them anyway, by looking for the stuff that's falling in. If material is falling into a black hole, it travels at such high speeds that it gets hot and glows very brightly, and we can detect that. That's how the Event Horizon Telescope took its famous first images of black holes. Scientists hope to use this method to learn a lot more about how and what black holes eat. By seeing their gravity pulling on other things, we can find black holes by watching the movements of visible objects around them. For example, a black hole's gravity is so strong that nearby stars will orbit around them, so we can look for stars behaving strangely around a patch of empty space. From this, we can calculate exactly how heavy the black hole must be. That's how Nobel Prize winner Andrea Ghez and her team detected the supermassive black hole at the center of our own galaxy. What's inside a black hole? The short answer is that no one knows. In some ways, that's one of the most profound questions in physics, said University of Chicago professor Daniel Holtz. There are not many cases in physics where we simply cannot predict what happens, but this is one of them. Black holes have two parts. There is the event horizon, which you can think of as the surface, though it's simply the point where the gravity gets too strong for anything to escape. And then, at the center, is the singularity. That's the word we use to describe a point that is infinitely small and infinitely dense. We have a good understanding of what the event horizon looks like, thanks to the laws of general relativity. But as you get close to the singularity itself, we lose the ability to even predict what it looks like. Very near the singularity, one would expect quantum effects to become important. However, we don't yet have a quantum theory of gravity, or at least one capable of reliably making such predictions. So we just don't know the correct description of the singularity, or even whether it really is a singularity, said University of Chicago professor Robert Wald. Scientists think that black holes eventually will explode, but it will take many, many times longer than the current age of the universe for that to happen. What will it look like when that happens? That's another big mystery. Maybe there's a little nugget left behind containing all of the information that fell into the black hole. Maybe there's a portal to a new universe. Maybe the information is just gone forever. We simply don't know, said Holtz. How do black holes form? Scientists know about one way that black holes form, but there may be others. One way to make a black hole is to have a massive star collapse at the end of its life. Professor Subramanian Chandrasekhar was the first to calculate that when a massive star burns up all its fuel, it will collapse. The idea was ridiculed at first, but other scientists calculated that the star continues forever to fall inward towards its center, thus creating what we called a black hole. Black holes can grow more massive over time as they eat gas, stars, planets, and even other black holes. There's another type of black hole called a supermassive black hole. These are way too massive to have been created by one star collapsing. It's still a mystery how they form. Black holes can eat other black holes, so it's possible that the supermassive ones are made of many small black holes merged together. Or perhaps these big black holes were especially hungry and ate so much of their surroundings that they grew to enormous size, said Professor Holtz. But we can see these supermassive black holes formed very early on in the universe, maybe too early to have been made by stars getting old enough to collapse. So it's possible there's some other way to make a black hole that we don't know about yet. What is a supermassive black hole? There are two kinds of black holes: star-sized black holes and supermassive black holes. Supermassive black holes are so named because they contain on the order of millions to billions of times the mass of our Sun. As far as we can tell, nearly every galaxy in the universe has one of these supermassive black holes sitting right at its center like a seed. And they are correlated. A bigger galaxy has a bigger black hole, and a smaller galaxy has a smaller black hole. All of this makes scientists think these supermassive black holes have something to do with how the galaxies formed. But that relationship is still a mystery, and so is how the supermassive black holes formed in the first place. Our neighborhood supermassive black hole, the one at the center of our own Milky Way galaxy, is called Sagittarius A star. It's about 15 million miles across and contains the equivalent of 4 million suns worth of mass. Don't worry, it's much too far away to pose any danger to Earth. What do black holes eat? Contrary to what you may have seen in movies, black holes don't actually suck things in. For example, there are actually stars orbiting the supermassive black hole at the center of our galaxy, and they'll keep orbiting without falling in unless something else disturbs them. An object really has to fall right into the mouth of a black hole for it to be eaten, and the mouth, which we call the event horizon of a black hole, is tiny. If the entire Earth were to collapse and form a black hole, its mouth would be less than an inch across. But the movements of stars and galaxies do sometimes mean that stuff falls into a black hole's mouth. Sagittarius A star, the black hole in the center of our galaxy, mostly eats interstellar gas and dust that is drifting around. With telescopes, we have seen other black holes eating stars and even the gas from neighboring galaxies. Black holes can be messy eaters. As objects are being ripped apart, some of the gas and matter can be flung off at high speeds. Sometimes this is so powerful that it forms jets and winds shooting outward at nearly the speed of light, and this can affect the galaxy containing it. These jets can blow apart nearby stars and planets, or they can provide just the right amount of churn to create the ideal conditions for making new stars over millions of years. How were black holes discovered? The first inkling that anyone had about black holes came when 19-year-old astrophysicist Subramanian Chandrasekhar was mulling over the consequences of several recent discoveries, including Einstein's theory of special relativity. Scientists at the time were shocked and skeptical. The most famous astrophysicist at the time, Arthur Eddington, publicly trashed the idea at a gathering, saying, "I think there should be a law of nature to prevent a star from behaving in this absurd way." However, the damage was done. Once the astrophysics community had come to grips with a calculation performed by a 19-year-old student sailing off to graduate school, the heavens could never again be seen as a perfect and tranquil dominion. Physicist Freeman Dyson later wrote. Scientists soon worked out that other laws, including Einstein's theory of general relativity, required black holes to exist. The idea became increasingly accepted. In the latter half of the 20th century, eminent theoretical scientists, including Stephen Hawking at Cambridge, John Wheeler, and Jacob Bekenstein at Princeton, Chandrasekhar and Robert Wald at the University of Chicago, and many others, explored the details of the mathematics and physics behind black holes. Meanwhile, evidence from telescopes began to pile up that black holes were out there in the universe. Thank you for watching, and please hit the like button, subscribe to the channel, and enable post alerts to view more of our future videos. After saying that, keep watching our videos, and I'll speak with you in the next one.